My name is Henry, and welcome to my model walkthrough for optimal pricing using price elasticity. Now, this presentation kind of explores how small businesses like local bakeries and stuff can use economic modeling to find the price that maximizes profit for them. So I chose this model because it's pretty simple, it's practical, and it can be applied to almost any businesses that sell a product. Personally, I run a business and I use this model a lot to make sure I know what I'm selling and if it's at the best price. Um, by the end of this presentation, you'll understand not just how to calculate the optimal price, also why it makes sense from both a business and economic perspective. Now, second slide. Sorry. Managerial scenario. So let's start with a real world example. Imagine I'm the owner of a small bakery to introduce a new product called the Cronut Deluxe. It's a mix between a croissant and a donut. And we're trying to decide how much to charge for it. If we set the price too high, customers are just going to go to other stores. But if we set it too low, I would be losing out on profit. So we need to find out the perfect price to sell it at to maximize profit, which is what the goal is. Find the price that gives you the highest weekly profit. Just who might use this model? Mainly managers and business owners, but only the managers that would really get assigned the task, as most of the time managers' pay doesn't really reflect the sales of a company, but it'd mostly be business owners as they are the ones who are getting paid from the customer. They want to make the most money. So for sure, it'll be them who's worrying about this model the most and who would be utilizing this model. Now, slide through. Here's the setup of our model. The demand equation for our cronuts is estimated to be around Q equals 120 minus 2P. That means when the price goes up by $1, we'll expect to sell two fewer cronuts. Our marginal cost, the cost to make one more cronut, is $10. It includes ingredients, packaging, and labor. Now, we'll assume the market is small and local, and there's no price discrimination. As I said like before, then we can produce as many cronuts as we want for the constant cost of $10. So here the goal is pretty simple. Find the price and quantity combination that gives us the biggest profit. And since our profit equals total revenue minus total cost, that's what we're going to focus on next. Just for some assumptions, just to make it completely clear, there's no price discrimination, like I said before, so we can make as many of these cronuts as we want for the $10. There's always going to be a marginal cost, so the $10 will always be there, and there's always going to be local demand. Now, to find total revenue, we have to multiply the price by the quantity. But because price and quantity depend on each other, we need to rewrite the demand equation. And we need to make it so it's expressed in a function of quantity, sorry. So from Q equals 120 to 2P, we'll get the inverse demand of P equals 60 minus 0.5 Q. This means that we sell zero cronuts. The highest possible price someone would pay is $60. And if we sold 120 cronuts, the price would drop to zero. Now, we can calculate the total revenue with this equation as total revenue equals P, price, times Q, which equals 60Q minus 0.5 Q squared. This equation shows that the total revenue first increases as we sell more, but eventually decreases because at the lower prices, even though we sell more, each cronut brings in less and less money. This concept that revenue rises and then falls is mostly the key understanding why there's a single price that maximizes profit. It also falls into optimization. Now, next, we need to find the marginal revenue, which is the extra revenue we earn from selling one additional cronut. So when we take the derivative of the total revenue, we get MR, marginal revenue, equals 60 minus Q. In economics, mostly we know that when profits like maximize, where marginal revenue equals marginal cost. So at this point, that's what's happening. We normally want to set marginal revenue to marginal cost, or 60 minus Q equals 10. Solving that equation gives you Q equals 50. And that means you're going to be selling 50 cronuts per week. If we sell more than 50, then the cost of me making each additional krona outweighs the extra money we earn. But if we sell less, we're leaving more money on the table. So 50 is kind of like perfect in between for maximizing profit. And we use that getting using optimization. Now, finding the optimal price. Now we know that the best quantity, what the best quantity is, which is 50. And we can plug it back into the demand equation to find the best price. As you can see here, this is the equation. And so this tells us that our optimal price is $35 per Krona Deluxe. At this price, we'll sell 50 units per week. So the total revenue will be 1750 and a total cost will be 500, which leaves a weekly profit of 1250. Now, this is a pretty powerful result. It shows the best price isn't necessarily the cheapest one, but charging $35 gives us fewer sales than a low price would, but we're making more money per krona, which would maximize our profits and give us the best possible way. Now, here's a graphical representation. The blue line shows the demand curve, which slopes downward, meaning as the price decreases, more people are willing to buy. The red dashed line shows marginal revenue, which drops twice as fast because each time we lower price to sell one more krona, we earn less revenue from all the others having the lower price too. Where the marginal revenue and marginal cost intersect, that's our equilibrium point. It's what happens at Q50 and P35. If we get a higher price, we'll sell too few kronas. But if we set a low price, the sales wouldn't make up the lost profit. So this graph visually confirms all the math behind our model, or all the math behind our model. Now, price elasticity. Next, let's check if our result makes sense using elasticity, which kind of measures the price changes in response to the demands. So from our demand equation, our slope is -2. So E equals dq over dp times P over Q times 35 over 50, which is around minus 1.4. Since the absolute value of elasticity is greater than 1, the demand is elastic. That means customers respond strongly to price changes if we raise the price slightly. This pretty much matters because firms always maximize profit and not the elastic part of the demand curve. So if the demand were inelastic, raising prices would increase revenue but reduce total profit because fewer consumers would buy. So you would just be able to jack up the price as much as you want and nobody can do anything about it because they keep buying it. That's what inelastic would be. But the graph shows, sorry, this matters because the graph kind of shows the difference visually, and the blue line represents the elastic demand, where quantity changes a lot with price, and the orange line kind of represents the inelastic demand, where it kind of barely changes, and you can see how it affects each other. Now, if costs change, let's test out our model, if our model reacts to if conditions change. Suppose ingredients cost rise and our marginal cost is from $10 to $15. So setting the marginal the MR, the marginal cost again receives 60 minus Q equals 15. So Q equals 45. This means our bakery should raise its price around to about 37.50 to expect to sell all around 45 kronas. This makes intuitive sense. When costs go up, the businesses need to raise prices to maintain profitability. So this isn't just static, it's flexible, and you can quickly recalculate prices or costs when input costs change. So lastly, to wrap things up, this model kind of shows that profit maximizing point for any product where marginal revenue equals marginal cost. Now, for the Krona Deluxe, that point is a price of $35 a unit and a quantity of 50 sold per week, which gives us a profit of 1250, so 1,250, which is probably the most you're going to making. And that's why it shows this approach is not just powerful, it's good because it can show how you can maximize your profit. And that's especially good for small businesses because they need every bit of profit they can get. But I hope you like my presentation. Thank you so much for listening. Have a great night.